play the Wheel of Unfortunate, you need $3 for 2 spins. You then spin the wheel and you have the chance of landing on a subtraction, addition, or bankruptcy of money. If you land on the black bankrupt section on your first turn, then you do not spin a second time and don't get your money back. If you land on the black bankrupt section on your second turn, then you do not get any of your money back.
For our math, we have a probability tree for all the potential outcomes while spinning the wheel. These outcomes include +1, +2, +3, -2, -3, -4, and bankrupt. The numbers in blue represent the occurrence of each number on the wheel. Since there were a total of 19 sections, we would place the occurrence as a fraction over 19. We would conduct the math by multiplying the branches. 19 times 19 would equal 361. Therefore, the final probabilities and outcome should have a denominator of 361. For instance, 4 times 2 would be 8, and we would place it over 361. The expected value of revenue our game was to bring in came from finding the sum of each potential spin multiplied by their probabilities. Since the probability for both spins did not change, we could just use one table. Our expected probability was around $1 to $2.
Oh my God! Alright, I'm at $0 right now. Ooh, so what does that turn out? I get $2 back? Alright, lost $1.
On casino day, after 20 plays, we made a net gain of $70. This can be found by getting our final amount of $110 minus our initial amount of $40. If you recall, our expected value was less than $2. Our experimental earnings per play nearly doubled, coming in at $3.50.
How well does your experimental earnings per play match your expected value? Do you think you had enough people playing your game?
Our earnings came out to be about $3.50 per play from each player that came to our game. This was more than what was initially paid before playing the game, which was $3. I think we had enough people playing our game since we ended up getting an added 50 cents on top of the initial pay of $3. This gave us a larger amount of money than expected.
Did you charge an appropriate amount for your game so that you can make money? Why or why not?
We charged just the right amount of money so that we could make more because since it wasn't a high amount of initial pay, this gave us the chance to almost save ourselves from losing money if the player won a high amount in the game. If the player applied the law of large numbers to our game, it was difficult to predict an outcome because there were more chances to lose money instead of gaining money.
What would you change about your game if you could do this project again? If we had the chance to do this project again, we would make a more sturdier wheel so that it would spin better and evenly, and also include more wins so that it would be a bit more fair.